Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at the Pi Day competition examination for this year, which is sponsored by a Cameroonian association called Promo Maths, which is out to promote the study of mathematics. So in the one of the videos that I just did is uploaded to this channel already. We're looking at equation from Premier section, and in this video we are going to be looking at a particular question from the Terminale section. So where is that question? Okay, so I thought of solving question 45 to question 49 and question 50 to question 54, but in this video I'm going to begin with question 50 to question 55, sorry, to question 54. All right, so like I said in the previous video that I'm going to upload this paper as well to the description, the link, so that if you're interested in getting the paper you can get. Don't bother that the questions are in French. I'm going to try my best to translate. Okay, all right, question 50. We have given two sequences un and vn defined by, we have u0 is e cubed, un plus 1 is e times the square root of un, and vn is the ln of un minus 2. Determine the common ratio of the geometric sequence v of n. 51. Express v of n in function of n. 52. Express u of n in function of n. 53. Calculate the limit of the sequence vn. 54. Calculate the limit of the sequence un. Alright, so that's what we are going to look at in this video. In subsequent videos you can as well propose a question that you need its solution, so I solve. Alright, so I am going to crop the question and then we solve together. So let us begin with this first part, that is question 50 first. Okay, alright, so question 50, here is it. Okay, so we have two sequences, okay, and we need to get the common ratio of the geometric sequence v of n. We know that the common ratio is r, and it is simply the ratio between the n plus 1 term and the n term. So vn plus 1 divided by vn. Now what is vn plus 1? It is the ln of un plus 1 minus 2, then divided by vn, and vn is the ln of un minus 2, the ln of un minus 2. Alright, so our common ratio becomes, now what is un plus 1? So we have the ln, let's just write our denominator, the ln of un first minus 2. Now what is un plus 1? So we have the ln, un plus 1 is e times the square root of un, as you can see. Then we need to subtract 2. Alright, so from this we can say we have, just copy back the denominator and we try to simplify the numerator. Now the numerator, we can write this ln as the ln of e. Okay, the ln of e, then we add it to the ln of the square root of u of n, then we need to subtract 2. So it means that our common ratio will be equal to, the ln of e is 1, so we are just going to allow the denominator, because we cannot do anything with the denominator again, we cannot further simplify. The ln of e is 1 minus 2 is negative 1, so we have negative 1 plus, now the ln of the square root of un is the same as un raised to the power half. Okay, now from the law of indices, or that's from the law of logarithm, there's a law that says that this half here will just multiply the logarithm of the argument. So we have the same denominator, so our denominator is the same, but the numerator becomes, we can even remove this negative 1 from here and we put the -1 here. Okay, so we have instead half times the ln of un n -1. Okay, now from the numerator we can do the LCM. In the numerator we can do the LCM, and we are going to have half into the ln of un -2. Okay, you see, if we distribute the half will come here, you get the first term, and then 2 divided by 2 will give you 1. Now you can put like the half outside, and then at the end of the day we have the numerator and the denominator have the same value, so they cancel off. At the end we get half, which is a constant. So we can conclude that hence the common ratio of v of n is equal to half. Alright, we are done with 50. Now I will go back to the equation set, and then I crop the remainder of the equations. So we now have to solve 51 to 54. Alright, so let me just put that here, and then so 51 to 54, here's the set of equations. So let's begin with 51 first. It says express v of n. 51, express v of n as a function of n. So since v of n is geometric and we have information about u0, right, we can get v0. So our v of n will be equal to v0 times r raised to the power n. What is v0? So let's get v0. Our v0, remember that our v of n is equal to the ln. Let me just try to decrease this since you are done with it already. Our v of n is the ln of u of n -2. So it means v0 becomes the ln of u0 -2. So we have the ln. Our u0 is e cubed, then -2. But ln e cubed is 3 ln e -2. And ln e is just 1. Times 3 is 3, -2 is 1. Okay, so it means that our vn is equal to v0 1 times our common ratio 1 on 2 raised to the power n. So at the end we can write it as 2 raised to the power -n. 52, express u of n in terms of n. Now since we have v of n to be equal to the ln of u of n -2, we can get the ln of u of n, and then we get u of n subsequently. So the ln of u of n is equal to v of n plus 2. And what's v of n plus 2? Is 2 to the negative n plus 2. Okay, so it means that the ln of u of n, let me just recopy, is 2 raised to the power negative n plus 2. So we can take the exponential on both sides. So taking e raised to the power the ln of v of n, we just get u of n, and then we have e raised to the power 2 raised to the power negative n plus 2. So that is our u of n in terms of n as well. Okay, so we can verify if n is equal to 0, our u0, is it e cubed? Let us verify keenly. We add 2 on both sides, and then we have this. Alright, if n is equal to 0, we are going to have, because you can still write this as e squared times e raised to the power our 1 on 2 raised to the power n. Okay, it's the same thing. If n is 0, this quantity will be 1. E raised to the power 1 is e, then times e squared is e cubed. So the first term coincides. Now 53, calculate the limit of vn. So the limit of the sequence is the limit as n tends to positive infinity. So the limit as n tends to positive infinity of vn is simply equal to the limit as n tends to positive infinity. So the limit as n tends to positive infinity of what is Vn? Our Vn is half raised to the power n. Okay, and this limit will give you 0 because half is less than 1. If the interior here was greater than 1, the limit is going to give you positive infinity. If it was equal to 1, then the limit will give you 1. And finally, 54, calculate the limit of the sequence un. So the limit of un is a limit at infinity, so un is equal to the limit as n tends to infinity. What is our u of n? This is our u of n. So we have this. Okay, now since e squared is a constant, we can pull it out of the limit, and we have we just have the limit of this guy here, which that is in terms of n. Okay, now as n tends to infinity, since this guy here tends to 0, e raised to the power 0 be tending to 1. So at the end we get that this is equal to e squared times 1, which is e squared. Alright, so guys, we are done with this video. Thank you for watching, and see you in the next video.